Assalamualaikum and hi Encik Asri. So this is my video for the assignment. The topic is about power conservation law, Ohm's law, KCL and KVL. For power conservation law, what we need to know is power is the time rate of expanding or absorbing energy that is measured in watt. The formula is power equal to voltage time with current. So let's look at the example. To find the power absorbed by each of the element, what we need to do is applying the formula and we will get the value that we need to find. For the Ohm's law states that the voltage V across a resistor is directly proportional to the current I flowing through the resistor. Ohm's law formula is V equal to IR. Look at the example that we have. Find the current through the resistor. Since we have R equal to 5 kilo ohm and V equal to 16 volt, V equal to IR, then we rearrange the formula, we'll get I equal to V over R, and the value for I we get 3.2 mA. For the example 2, what we need to do is rearrange the V equal to IR formula and we will get I equal to V over R for both question A and B. The difference between position 1 and position 2 is only the value of the resistor. Kirchhoff current law. Kirchhoff current law states that the algebraic sum of current entering a node or a closed boundary is equal to 0. We also can assume that current entering a node as positive while leaving the node as negative or vice versa. Let's look at example. Use KCL to find the branch current I1 to I4. Using the equation I in equal to I out, let's look at the circuit 1. For equation 1, we get I1 minus I2 equal to 2 ampere. For the circuit 2, we get I2 equal to 7 ampere plus 3 ampere. Then we will get I2 equal to 10 ampere. We already have I2, so we can substitute I2 to equation 1. Then do the same step to circuit 3 and 4 to get the value of I3 and I4. Example 2. Using nodal analysis, find VO in the following circuit. Basically, this topic is in chapter 4. Later on, you will learn about this topic. Now, let's look at example how we apply KCL into nodal analysis. Applying KCL at node 1, we will get negative V1 minus V over 8 plus 5 equal to V1 over 4 plus V1 minus V2 over 2. And then we rearrange the equation, we will get 7V1 minus 4V2 equal to 20. That one for equation 1. And then we applying KCL at node 2, we will get 40 minus V2 over 1 plus V1 minus V2 over 2 equal to 5. We rearrange the equation, we will get V2 equal to 70 plus V1 over 3. That one for equation 2. Since we already have equation 1 and equation 2, we can substitute 2 into 1. Then we will get 7V1 minus 4 bracket 70 plus V1 over 3 equal to 20. We rearrange the equation and we will get V1 equal to 20 volt. Kirchhoff voltage law. Kirchhoff voltage law states that the algebraic sum of all voltage around a closed path or loop is 0. When voltage sources are connected in series, KVL can be applied to obtain the total voltage. The combined voltage is the algebraic sum of the voltage of the individual source. Look at example. Use KVL to find the branch voltage V1 to V4. We use equation V in equal to V out. Look at loop 3. 4 volt plus V3 plus V4 equal to 0. That one for equation 1. Then we move to loop 4. Negative V4 plus 2V plus 5V equal to 0. So we get V4 equal to 7 volt. That one for equation 2. From equation 2, we can substitute 2 into 1. Then we get V3 equal to negative 11 volt. Then we do equation for loop 1. Negative 3 volt plus V1 minus V3 equal to 0. Applying the value of V3 into this equation, we will get V1 equal to negative 8 volt. Then lastly, do equation at loop 2. Negative V1 minus V2 minus 2 volt equal to 0. Applying the value of V1, we will get V2 equal to 6 volt. Look at example 2. Using KVL, solve for the mesh analysis. Basically, mesh analysis is in chapter 3. Later on, we will learn about mesh analysis. So, let's look at loop 1. We applying KVL at loop 1, we will get 2I1 plus 1 bracket I1 minus I2 bracket minus 60 equal to 0. We rearrange the equation, we will have 60 plus I2 over 3. So, that one for equation 1. Then we move to loop 2. We applying KVL at loop 2, we will get 1 bracket I1 minus I2 bracket plus 3 bracket I2 minus 2 bracket plus 1 bracket I2 minus I3 bracket equal to 0. We rearrange the equation, we will have negative I1 plus 5I2 minus I3 equal to 6. That one for equation 2. Next, let's move to KVL at loop 3. KVL at loop 3, we will get 1 bracket I3 minus I2 bracket plus 6I3 plus 4I3 equal to 0. We rearrange the equation and we will get I3 equal to I2 over 11. That one for equation 3. When we move to loop 4, since loop 4 have current source, so we will directly get the value for I4, that is 2 ampere. Then, we substitute 3 into 2, we will get negative I1 plus 5I2 minus I3 equal to 6. Negative bracket 60 plus I2 over 3 bracket plus 5I2 minus I2 over 11 equal to 6. Then we rearrange the equation and we will get I2 equal to 5.6821 ampere. Then we substitute 2 into 1. I1 equal to 60 plus I2 over 3. Then we will get 60 plus 5.6821 over 3. And the value for I1 we will get is 21.89 ampere. Then we substitute I2 into equation 3. I3 equal to I2 over 11 equal to 5.6821 over 11. And I3 we will get 516.55 ampere. For I4, since we have current source, then the value is 2 ampere. Next, step for circuit analysis. 1. We need to determine the current direction that enter and leaving each nodes. Second, we need to assign that positive and negative sign for each elements. Current flow positive to negative in branch. Third, obtain the voltage across each element by applying Ohm's law. If the current flow through positive terminal sign, thus V equal to positive IR. Otherwise, if negative terminal sign, thus V equal to negative IR. When we applying the KVL, choose the direction of loop either clockwise or counterclockwise. Each loop must not overlapping. Obtain the KVL equation based on the chosen loops, clockwise or counterclockwise. If the loops enter positive terminal sign, thus positive V. Otherwise, if negative terminal signs, negative V. For KCL, obtain the equation by assuming if a current enter a node as positive I and leaving a node as negative I. For the conclusion, we know that voltage is a measurement of potential between 2 points. For the power conservation law, we know that power is equal to voltage times with current and the unit is watt. However, for the Ohm's law, we need to know that the equation for Ohm's law is V equal to IR. Voltage is equal to current times with resistor. Lastly, for the KCL and KVL, we also know that Kirchhoff's law tells us how the voltage and current in different branches are related. KCL is I in equal to I out, while KVL is V in equal to V out. Thank you for watching my video.